Okay, welcome to our regular geometry videos. This is Unit 4, question number 69. It says, Eddie is arguing with Tana about the probability of flipping 3 coins. They decide to flip a penny, nickel, and a dime. Which should be better for determining the sample space, a tree diagram or an area model? Well, for this particular one, I'm going to say a tree diagram because we have 3 separate things going on, a penny, nickel, and a dime. And it's hard to represent 3 relationships in an area model. That's usually we get 2, right? We make columns, we make rows. We need a third dimension there to represent the third coin here. So a tree diagram would be better. Part B, make a sample space that shows all the possible outcomes. So I'm going to flip to another page here and let's actually draw this out. So the first, so it's like the 3 coins, right? I'm sure they were penny, dime, nickel, something like that. So the first coin gets flipped and it has 2 choices. It's either heads or it's tails. And then from there, the second coin that gets flipped from each of those, which is either heads or tails. And then from there, the third coin is flipped, which is either heads or tails. Okay, so there's what our tree diagram should look like. Get back to the question was, how many outcomes are there? Okay, well that's easy. We just look at how many possibilities there are at the end here. And it looks like there's 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 total possible outcomes from flipping 3 coins. Find the probability of each of the following events occurring. Be sure to show your thinking clearly. So 3 heads, 1 head, 2 tails, 1 tail, and exactly 2 tails. Okay, so let's start with 3 heads first. Okay, so going back over here, the probability of flipping 3 heads, so it needs to be heads for each instance there. So there's that one, there's that one, that one. So there's one instance here where 3 heads are flipped. So that is 3 heads, that is 1 out of 8 possibilities. So let's go back, write that in. So the possibility of 3 heads is 1 out of 8. 1 head and 2 tails. Okay, so let's go back and check this out. 1 head and 2 tails. So it could be head, tails, tails. So there's 1 that we can do. 1 head and 2 tails. Let's see, it could go tails, head, tails. There's another possibility. Or it could go tails, tails, heads. So it looks like 3 out of 8 for a probability of that. So I'm going to those marks for now. So 1 head and 2 tails would be 3 out of 8. At least 1 tail, so that means it could end up with 1 tail, 2 tails, or 3 tails in this instance. So we're just looking at every possibility in which at least a tail occurs. So there 3 tails occurred, there 2 tails occur, there 2 tails occur, and there 1 tail occurs. There's 2, there's 1. Okay, so it looks like 7 out of the 8 possibilities involve at least 1 tail. Oh no, didn't mean to undo all of that. There we go. Okay, so 7, that could have been bad. Okay, so 7 out of 8 of those have at least 1 tail. And then exactly 2 tails. Okay, let's go back. We're looking for lines here that have exactly 2 tails. So that's 3. There's exactly 2 tails. There's exactly 2 tails. Nope. There's exactly 2 tails. Nope, nope, nope. Okay, so 3 out of 8. Again. So 3 out of 8 for 2 tails. Okay. Which is more likely? Flipping at least 2 heads or at least 2 tails? Explain. Well, I think it's going to be the same probability, right? It's the same probability of flipping a heads, or flipping a tails. So flipping at least 2 heads is the same probability as flipping at least 2 tails. We can go back to the picture and look here. So at least 2 heads would be all the ones that have, these 2 H's along them. So there's one with 2 H's, 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 and that's it. Okay, now, so there's 4 out of 8. Let's see ones which at least have 2 T's. So there's that one which has 3 T's, that one has 2 T's, nope. So we got that one, we got that one, we got that one, nope, and that one. And then there's just 1 T, and no T's. So we have 4 that have 2 heads, we have 4 that have 2 tails. There's an equal probability that we could get either 2 heads or 2 tails. So this will be the same probability. How would the probabilities change if Tana found out Eddie was using weighted coins? The probability of getting heads was 4/5 instead of 1/2. Would that change the sample space? We calculate the probabilities in part C based on the new information. Okay, so if the probabilities were 4/5 for getting heads, that would change some stuff here. So let's go back over here. And now this is now going to be 4/5. This is 4/5. This is 4/5. This is 4/5. Each time its probability of getting heads, it now changes to 4/5. Which means the probability of getting tails is 1/5. So these are all 1/5 now. Okay, so I'm going to recalculate all these probabilities. So we have 4/5 times 4/5 times 4/5, which is 64 1/25. 4/5 times 4/5 times 1/5, which is 16 1/25. This is 4/5 times 1/5 times 4/5, which is also 16 1/25. And 4/5 times 1/5 times 1/5, which is 4 1/25. I'm going to turn these into percentages later. 1/5 times 4/5 times 4/5 is 16 1/25. 1/5 times 4/5 times 1/5 is 4 1/25. 1/5 times 1/5 times 4/5 is 4 1/25. And 1/5 times 1/5 times 1/5 is 1 1/25. Okay, let's change these into percentages. 1 1/25 is 0.8%, so not very likely of happening. 4 1/25 is 3.2% chance. Sixteen 1/25 is a 12.8% chance of happening. And 64 1/25 is a 51.2% chance of happening. Okay, so as we can see, these things are drastically skewed now. Before, where the probability of getting 3 heads and the probability of getting 3 tails was the same, now the probability of getting 3 heads is about 50%. The probability of getting 3 tails is less than 1%, it's a 0.8% chance, right? And the probability of these ones that incorporate more than 1 head, so like 2 heads and a tail, And that's at 12.8%. Here's another 2 heads and a tail at 12.8%. And here's another 2 heads and a tail at 12.8%, versus the probability of getting 2 tails and a head, that's down at 3.2%. So the probabilities that involve getting heads here over tails are a lot greater. Right? The probability of getting 3 heads is like about 52%. 1 head and 2 tails, that was down at like the 3.2%. The exactly 2 heads, that was up at like the 12.8%. And obviously there's more than one instance of each of those, so you have to add those together. So it'll be like 12.8 plus 12.8 plus 12.8 in order to get those. So definitely that is going to change the samples. Well, it's not going to change the possible outcomes, but it will change the probability of those possible outcomes, extremely favoring the heads. So, and these are the probabilities associated with it. Okay, if you have any questions about how I set up that tree diagram or how I calculated those probabilities, especially once we put those weighted probabilities in there, feel free to leave any questions or comments you may have. Otherwise, you're welcome to share your comment.